Activity 5. To separate common salt dissolved in water. Things needed: common salt, water, china dish, burner, tripod stand, wire gauze. Method: dissolve a teaspoonful of salt in about 50 milliliter of water taken in a china dish. Place the china dish on the tripod stand. The solution of common salt and water taken in the china dish is heated gently by using a burner. Observation: the water present in the salt solution evaporates to form steam. When all the water present in the solution of common salt and water gets evaporated, common salt is left behind in the china dish as a solid. Condensation. This method is used to obtain a liquid from its solution. We can get water from salt solution by this process. The process of changing vapor into its liquid state on cooling is called condensation. Activity 6. To separate water from a mixture of salt solution. Things needed: common salt, water, aluminium kettle, frying pan, beaker, gas burner, tripod stand, wire gauze, ice cubes. Method: dissolve about 20 gram of common salt in water to obtain a common salt solution. Pour the salt solution in the aluminium kettle and put the lid on. Place the kettle on the tripod stand. Also, place the gas burner below the tripod stand. Light the burner. Heat the kettle for some time. Steam comes out from the spout of the kettle. Take a frying pan with some ice cubes in it. Hold the frying pan in a slanting position, just above the spout of the kettle. We observe that when the steam comes in contact with the frying pan cooled with ice, it condenses to form droplets of water on the underside of the frying pan. These droplets trickle down on the underside of the frying pan and then start falling down. Collect these droplets of water in a glass beaker and taste it. It does not taste salty. The water so collected is called distilled water. Separation of mixtures by using more than one method. A mixture that has only two components can be separated by a single method. On the other hand, a mixture that has more than two components can be separated into individual components by a combination of methods of separation. These methods are applied one after another. Let us consider some examples. Separation of iron filings, ammonium chloride and sand mixture. To separate a mixture of iron filings, chalk powder and common salt into individual components. Water as a solvent. Water can dissolve many kinds of substances like sugar and salt. When we dissolve a substance in water, a solution is formed. Activity 8. Can water dissolve any amount of a substance? Things needed: a beaker, some common salt, spoon. Method: take a beaker and put 100 ml of water into it. Add 1 teaspoonful of salt to this water and stir it with a spoon until the salt dissolves in it. Go on adding more and more salt in water with constant stirring to dissolve it. Observation: after adding a number of spoonfuls of salt, we observe that some salt is left undissolved at the bottom of the beaker. This means that no more salt can be dissolved in the amount of water you have taken. The solution is now said to be saturated. Conclusion: water can dissolve any substance only up to a limit. In the above activity, we have obtained a saturated solution of salt in water. A solution in which no more substance can be dissolved at a given temperature is called a saturated solution. Solubility: different substances dissolve to different extents in water at a given temperature. For example, 204 grams of sugar can be made to dissolve in 100 grams of water at room temperature, whereas only 36 grams of salt can be made to dissolve in 100 grams of water at room temperature. In other words, sugar dissolves to a greater extent than common salt. The extent of dissolution of any substance is described in terms of solubility. The maximum amount of a substance that can be dissolved in 100 grams of water at a given temperature is called its solubility in water. Solubility of some common substances at 20 degrees Celsius is given below. Substance: solubility in water. Sugar 204 grams. Common salt 36 grams. Potassium nitrate 32 grams. Copper sulfate 21 grams. Activity 9. To prepare a saturated solution of sugar at room temperature and observe the effect of temperature on the solubility of the sugar in water. Things needed: sugar, beaker, spoon, burner. Method: take 100 grams of water in a beaker. Add a small quantity of sugar into the water. Sugar dissolves in water on stirring with a spoon. Keep on dissolving more and more sugar in the water with constant stirring until no more sugar dissolves. You find that some sugar is left undissolved at the bottom of the beaker. You have obtained a saturated solution of sugar. Now, heat the beaker containing the saturated sugar solution. What do you observe? The undissolved sugar at the bottom of the beaker gets dissolved. This shows that at higher temperature, more sugar gets dissolved. Now, let this hot solution cool. What do you observe? The sugar settles at the bottom of the beaker again. This shows that at low temperature, less sugar dissolves in water. Conclusion: heating of a saturated solution of any substance increases the solubility of the substance. If the saturated solution of a substance is cooled to a lower temperature, the solubility of the substance decreases and some of the dissolved substance separates in the form of crystals.